In this lecture, we will study water hammer. So, water hammer is a knocking noise in a water pipe that occurs when the tap is turned off briskly. Briskly means very suddenly. So, what happens is that water, and suppose the water is flowing through this pipe and there is a tap there. And if we close the tap, the flow of water suddenly abrupt. So then it reflects. So it reflects in this way. The wave goes this way and this way. So total, if we take a wave, common wave, general wave. So this is lambda. Okay, between two. This is lambda. So here this is okay. Here this is 2 lambda by 2. Okay, lambda by 2 equals to L. This is one relation. So generally we have to find time period. Okay, this is length and this is time period. Okay, the time period is 2L over C. 2L over C. Okay, 2. Okay, this is omega t. Okay, this is called omega t. This is lambda in space domain and omega t in time domain. So omega t is equal to L. Omega t is equal to L. Omega t by 2. Okay, omega t by 2. Omega t by 2 equals to L. So here t is equals to 2L over omega. Or we can see Ct. Okay, here speed of time is c. Omega is the general case. Here there is longitudinal wave. So Ct. So 2L over c. So what is the value of c here? So what is the value of the c? C is the there in a wave there are two kinds of velocity. There is phase velocity and there is group velocity. So phase velocity is the velocity of a particle at that position, and group velocity is the velocity of the wave itself. So what is the velocity of the wave itself in the water hammer case? So we will calculate this velocity by using energy conservation. So energy half mv square. So strain energy of the pipe material equals kinetic energy of liquid half mv square equals to strain of the liquid. Strain energy of the kinetic energy of the liquid gets transformed into strain energy of liquid plus strain energy of the pipe material. If we also consider pipe to be elastic. Okay, so kinetic energy of liquid is half rho v square into volume of the material here. Okay, so pi d square for area into L. So strain energy of the liquid is p square over 2k. Half is which this is in formula. If p, the pressure is p. Okay, so p square over 2k is the energy. This is similar to the cases where m square over 2 half ei is energy u. Suppose so this is also dimensionally similar. So p square over 2k into the volume of the water pi over 4 d square volume of the water. This is volume of the water. So kind of strain energy of liquid हो गया. So then strain energy of the pipe material. So strain of the pipe material को we will have to apply this formula. Total strain energy of the material is sigma 1 square plus sigma 2 square minus 2 mu sigma 1 sigma 2 over half E. Okay, so sigma h and sigma l we will have to calculate here. sigma h is the hoop stress and sigma L is the longitudinal stress in the pipe. Pipe is this. So if you cut the pipe, this stress and this is the pipe and we cut it longitudinally. This stress is called longitudinal stress. So hoop stress and longitudinal stress. We will calculate hoop stress by applying this relation. 2 into sigma h into thickness of the pipe is equals to pressure into 2r because this pressure is balanced by the strain in the pipe. Okay, and then longitudinal strain is also calculated similarly. So p into pi square area is balanced by circumference, so 2 pi rt into sigma l. So we get hoop stress is equal to pd over 2t and longitudinal stress is equal to pd over 4t. We substitute these values in this energy formula. Sigma 1 square plus sigma 2 square minus 2 mu sigma 1 sigma 2 का half EI. तो half E not I. So then we get this very simple result here: P square d square over 8 ET square. Then we put this that value in the strain energy of the pipe material here: P square d square 2 divided by 8 ET square into pi is volume of the pipe. So circumference into length, pi d into L, pi dt into L, area into length, area of the circumference. So area of the cross section into length. Then we so solve this equation here. The equation we get, then we get that half rho v square is equal to p square over k plus p square over e d over t. So p is equals to under root, or we can say p square is equal to rho over 1 over k 1 over dk det into v. So this okay. Finally, we get this value of the c, the CV which that was the group velocity of the wave. So k over rho. This is very simple. If we didn't have to consider the elasticity of the pipe, if it were rigid, all the velocity, all the strain energy would have been taken by the water. So okay, in that case, C is equals to any k, मतलब k of the medium divided by density of the medium under root. This is very simple, and there is a slight modification here due to the addition of, so 1 plus in the denominator we take 1 plus for the liquid, and dk over et is a ratio here, ducat, okay, dk over et. D is the diameter, k is the elasticity of the water, E is the elasticity of this pipe, and T is the thickness of the pipe. Okay, C is equal to K over. Then we can check whether the length 2L over C, the value 2L over C is less than or greater than the time of closure. Okay, so if the value 2L over C and if the value 2 over C is greater than the time of closure, we get a water hammer. Okay, that's it. Thank you.